Alright, so there is our exponential warm-up problems. The first one here is a growth, because it's growing. The domain of that is all real numbers. The range is y is greater than 0. The horizontal asymptote is y is equal to 0. The y-intercept is 0, 3. As x goes to positive infinity, the function is going to positive infinity. As x goes to negative infinity, the function is going to 0 from above. Okay. You've filled in the chart, but the chart numbers are, so -1 would be 3/2, 0 would be 3, and 1 would be 6. They're just everything. I'm not going to fill in my chart after this. Everything's going to be on the graph. I have the points that I want on the graph. Okay. Number 2 is an exponential decay. Okay. Its domain is all real numbers. Its range is y is greater than 0. Its horizontal asymptote is y is equal to 0. Its y-intercept is 0, 2. As x goes to positive infinity, the function goes to 0 from above. As x goes to negative infinity, the function goes to positive infinity. Okay. Oh, forgot intervals of increasing or decreasing. This one is increasing on the interval negative infinity to positive infinity. This one is decreasing on the same interval, negative infinity to positive infinity. It's always increasing, always decreasing. In general, the form of f of x equals a times b to the x. The y-intercept of the exponential growth or decay function will be 0, a. We learned that the other day. Okay. Page 1 done. In this lesson, we're going to explore transformations of exponential growth and decay functions. So what's going to happen is we're going to shift these graph. Transformations are shifts. We're going to shift them to the left. We're going to shift them to the right. We're going to shift them up. We're going to shift them down. We're going to narrow them up. We're going to widen them out. We're going to do all that fun stuff. Okay? So the parent function that we're going to go with for the first 4 is f of x equals 5 to the x power. Boom, it's right there. Okay? All right? Then the first thing that we did is we made the exponent negative. Okay? So a negative exponent changes it from an exponential growth to an exponential decay. And so basically what's happening here is we have a reflection in the y-axis. Okay. On the third one, we took our exponential growth function, and by putting the negative sign out in front, it reflected it in the x-axis. In number 4, we did it both. We put the negative out in front and we put the negative up in the exponent, and that became a reflection in the x-axis and in the y-axis. It's reflected in both. Okay. Okay. So then we asked you to fill out this chart, okay, with its reflections. Okay? For all of them, the asymptote is y equals 0. Okay? For all of them, the asymptote was y equals 0. For the first one, it was increasing for our parent function. It was increasing on the interval negative infinity to positive infinity. On g of x equals 5 to the negative x power, we said that one then was decreasing because it changed it from a growth to a decay. What about in number 3? Let me scroll back up here and see. Okay, it looks like it's a decay, but it is not a decay. It actually is an increasing function because the function is getting farther and farther away from the asymptote. Okay, so this one, it looks like it's a decreasing, but it is an increasing function because as we go farther and farther out towards positive infinity, it's getting farther and farther away from the asymptote. And then this one is a decreasing, again, on that whole interval. Okay? End behavior is what's going on the left and the right sides of the graph. So on the first one, on the right side of the graph, it's going to positive infinity. My function is going to positive infinity. And the left side, it's going to 0 from above. In the second one, in number 2, it's going to 0 from above on the right side of the graph, and it's going to positive infinity on the left side of the graph. In the third one, on the right side of the graph, it's going to negative infinity, and on the right side, it's going to 0 from below. On the last one, it's going to 0 from below on the right side of the graph, and it's going to negative infinity on the left side of the graph. Okay. So that was dealing with a values and how it affects your y-intercept and so on and so forth. So now we're going to look at some of these other numbers. So far we've looked at those, or we've looked at A. Oops, I got to put my marker back on. We've looked at A and the positivity of x. So now we're going to look at other things that move the function around. So we're going to start with our parent function of 3 to the x power. So at negative 1, the value of the function is 1/3. At 0, the value of the function is 1. At 1, the value of the function is 3. Okay? So the easiest, great point here now, the easiest exponents to put in are the 3 exponents that we ask you to put in all the way through. It's when the exponent is -1, when the exponent is 0, and when the exponent is +1. Those are the 3 easy ones to put in. The ones that you shouldn't have to use a calculator for to figure out. Okay? So if I put in here, okay, if I want to put in, I want x plus 1 in my brain, I want x plus 1 to equal -1, I want it to equal 0, and I want it to equal +1. So x plus 1 equaling -1 says I'm going to put in -2. X plus 1 equaling 0 says I'm going to put in -1. And x plus 1 equaling +1 says I'm going to put in 0 for x. Okay? Make it easy on yourself. Okay? So that's why I chose over here underneath the red ones, I chose -2, -1, and 0. Okay? Now, what happens to those two graphs? So the blue graph was my original parent function. The red graph is this 3 to the x plus 1 power. And what happened? Well, we horizontally shifted that graph one spot to the left. What happened to the domain? Well, the domain stayed all real numbers. That didn't change. What happened to the range? It stayed y is greater than 0. That didn't change. What happened to the horizontal asymptote? It stayed y is equal to 0. That didn't change. Okay? For horizontal shifts, those three values will not change. So all of those are the same. Only change is the y-intercept.
Technically, the question just says about these three, so
Right.
nothing changes.
Right, so nothing, that's why they're all the same, but the only change then would be the y-intercept, because it went from, what did it go from? Went from 1 to 3.
Yep.
Oh, Lens.
Thanks. So there, because that is minus 2 in the exponent, that means that's going to be a right 2 horizontal shift. The domain stays all real numbers. The range stays all positive numbers. The horizontal asymptote stays y equals 0. Okay, but the 3. So to make the easy 3, it would be 1, 2, and 3, because 1 minus 2 gets me negative 1, 2 minus 2 gets me 0, and 3 minus 2 gets me 1. Okay. Over here, again, now it's plus 3 there, so that is a left 3 shift. So negative 1 would go to negative 4, 0 would go to negative 3, and 1 would go to negative 2. But the domain, the range, and the horizontal asymptote all stay the same. Okay? So in general, describe what adding or subtracting value to the exponent does in the graph of the function without one. It shifts the graph left or right. And if you noticed, we are thinking opposite. Here in number 2, it was minus 2. We shifted it to the right 2. We went in the positive direction. In number 3, it was positive 3. We went to the left, which is the negative direction. Okay, so we think oppositely on those shifts. There it goes. Okay. So then now let's look at vertical shifts. Okay. 3 key points again would be negative 1, 0, and 1. They're all in the graph for you. Okay. The domain here now of the transformation, the domain of the blue, is all real numbers. That stays the same. The range of the blue is y is greater than 0, but the range now, because it was a vertical shift, the range of the red graph is y is greater than 2. The horizontal asymptote of the blue graph was y equals 0, but But since that all got shifted up, my horizontal asymptote is now y equals 2. Okay? This one, because it was a vertical shift, they all change. Okay? So here, my key points all stayed the same, okay? But the domain now of my red is all reals. The range, because it went down 2, the range is y is greater than negative 2, and my horizontal asymptote is y is equal to negative 2. Here, because it took the whole function and went up 1, the domain stays, but the range goes up 1, and the horizontal asymptote goes up 1. Okay? In general, what happens with that is it becomes a vertical shift. And for this one, we think normal. If it's positive, it goes up. If it's negative, it goes down. And that is it. This is a homework
Go, let's go. Go, let's go.
video. The keyword that you need to put on a sheet of paper and turn in on Monday is Figgy